Hello students, I hope you have understood the topics that we have covered in the last video. We have discussed about the mass, volume, density, SI units. These all terms that we often use while we study chemistry. Okay, so in this topic we are going to study about the scientific notation and how can we use the scientific notation while we do the numerical calculations. Numerical calculations like subtraction, addition, multiplication, division and everything. And what is the scientific notation? The scientific notation is that while we study chemistry, we are using the numbers which is very large or very small. Two large numbers or two small numbers. So we know that chemistry is a micro science. So we are doing with very small particles that we can't even see through our eyes. So very small numbers are there and there are numerous number of particles are there. So we are dealing with a very large numbers also. So when we do the calculation using these numbers, it will be difficult for us. So scientific notation is a convenient way. It's a convenient way to express these numbers. That is two large numbers or two small numbers. So when we express these numbers in a scientific notation, it will be very easy for us to do the calculations and all. Okay, so in this session we are going to study how can we express a number in scientific notations, and using scientific notations how we can do the addition, subtraction, multiplication and divisions also. Okay, so we can watch this video. Okay, thank you students.
Scientific notation. So, what is the scientific notation? So, in chemistry, we are often using very large numbers or very small numbers. So, scientific notation is a convenient way to express a very large number or a very small number. So, in order to express very large number or very small numbers, we will be using scientific notation. So, scientific notation has a general formula n into 10 raised to n, where capital letter N has a value between 1 to 10 and small letter n is the exponent over here. So, capital letter N will be having a value between 1 to 10 and small letter n is any exponent. It can have either negative value or positive value. So, we can do one example to study more about the scientific notation. All of you might have heard about the Avogadro number, right? So, Avogadro number is a very large number. So, I have written the Avogadro number over here. So, while we are doing the calculation, if we are using the Avogadro number like this, we won't be able to do the calculation very fast. So, what we are doing is we will be doing the scientific notation of it. So, capital letter N, we know that it has a value should be between 1 to 10. So, in the Avogadro number, it will be the first digit, that is 6. So, we will be writing 6.022 into 10 to the power of. Then we need to find out the power. So, in order to find out that exponent, what we need to do is we have taken 6.022. After that, how many zeros are there? So, since this number has no decimal point, the decimal point will be lying at the end of that digit, right? So, we need to count the number of zeros such that the decimal point will come to the next to that of 6. So, you count it. So, when we are counting, we will be getting 23. 23 digits are there. So, we will write the exponent n as 10 to the power of 23. Since the decimal points are shifting to the left side, we will be using a sign of positive. Positive 23. So, 6.022 into 10 raised to 23 is the scientific notation of Avogadro number. Okay. So, capital letter N should have a value between 1 to 10, then into 10 to the power of some exponent. That exponent we will be getting when we count the number of digits that we need to count to shift the decimal point. Next example, 0.00016. So, capital letter N. What should be the capital letter N? 1.6. Here there will be 16. The digit 16 is the, so we will be writing 1.6 into 10 to the power of, what is the exponent? How many digits we need to shift? 1, 2, 3, 4. Right? So we will be writing 4 over here. Since the decimal point is shifting towards the right side, will be the sign of that exponent will be negative. If the decimal point is shifting towards the left side, then we'll be using positive sign, and if we are shifting it towards the right, then we'll be using a negative sign. Okay, so this is the scientific notation of the digit 0.00016. So we can do one more example. For example, 342.02. So what will be the scientific notation? So capital N should have a value between 1 and 10. So it will be 3.4202 into 10 to the power of, how many digits we have shifted? 2. So we will be writing 2 over here. Again we have shifted the decimal to the left side, so the sign will be positive. Okay, so this is the scientific notation. Again, scientific notation is a convenient way to express very large number or very small numbers. So I hope you have understood to express a particular digit in its scientific notation. The only thing that you need to do is find out the cap letter and find out the decimal point, how many decimal points you need to shift, and mark it as the exponent. Okay, so the next topic that we are going to study is about the multiplication and division. So in chemistry we will be doing with long calculations. So how can we use the scientific notation in the multiplication and division, all the numerical calculations, multiplication, division, subtraction, or the addition, in all these numerical calculations, how can we use the scientific notation? So first we will be studying about the multiplication. For example, I have taken digits 5 into 10 raised to 3 into 2 into 10 raised to 4. So how can we multiply? For that, we just need to multiply the digits, that cap letter N over here. That is 5 into 2. So 5 into 2 is 10. Then you have to write into 10 to the power of. 10 to the power of, you take 3 and 4 others. So you just need to add it. So 3 plus 4 will give you 7. So 5 into 10 raised to 3 into 2 into 10 raised to 4 will give you 10 into 10 raised to 7. So if the calculation is multiplication, you just need to multiply the digits and you have to add the exponents. Okay, so we can look at the next example. 10 into 10 raised to 4 divided by 2 into 10 raised to 2. So again what we have to do? Do the division first. Take the calculator N and do the division first. So 10 divided by 2, it is 5. 5 into 10 to the power of 4 and 2 is there. Since it is a division, what we need to do is you have to subtract it. 4 minus 2. So you will get 5 into 10 raised to 2 as the answer. So if it is a multiplication, you need to add the numbers leaving the exponent term over there. Then you have to add the exponents. So we'll get the multiplication. So if it is a division, again you need to divide the numbers and you have to subtract the exponents. So there we will be doing with the multiplication and division using the scientific notation. So now it is addition and subtraction. Addition and subtraction is much more difficult than that of the division and the multiplication. For addition and subtraction, in order to do the addition and subtraction, we need to make the exponents as the same. But for multiplication or division, no need to make the exponents the same. You just need to add or subtract the exponents. But in order to do addition and subtraction, we need to make the exponents same. Okay, for example, 6.65 into 10 raised to 4 plus 8.95 into 10 raised to 4. Here the exponents are same itself. So since the question itself the exponents are same. So what we need to do is, just like how we have done the multiplication and division, you need to add the digits together. 6.65 plus 8.95 and make that 10 to the power of 4 as the common. So that's why we are saying that it should be the same. It's then only we can take it outside. So that 10 to the power of 4 is common to both the numbers. Then what we have to do? We have to add the two numbers and we can write the answer over here. 15.6 into 10 raised to 4. Okay. So we can do another example with the different exponents. For example, 6.65 into 10 raised to 4 plus 8.95 into 10 raised to 3. Here the exponents are different. The first digit has an exponent of 10 raised to 4 and the other one is having a exponent of 10 raised to 3. So we need to make it same, 10 to the power of 4 and 10 to the power of 3. So what we have to do is 6.65 into 10 raised to 4 plus, I am going to make the second digit exponent same as that of the first digit. So 10 raised to 3 I need to change into 10 raised to 4. So 3 should be changed into 4. So what should I add? Plus 1. 3 plus 1 will give you 4. So positive sign, right? Positive sign means the decimal point is shifting towards the left side. We have studied it in the scientific notation. Since the change in the exponent is plus 1, we'll be shifting the decimal point one digit to the left. So we'll get 0.895. 6.65 plus 0.895 into 10 raised to 4. 10 raised to 4 is the common exponent over there. So we'll get the answer as 7.545 into 10 raised to 4. So what we have done here is we have made the exponents same. We have made the exponents same by shifting the decimal point. We have changed the 10 raised to 3 to 10 raised to 4. So the change is plus 1. So in order, if it is a plus sign, then what should I do? We should shift the decimal points to the left side. So the next example we are taking is 2.5 into 10 raised to minus 2 minus 4.8 into 10 raised to minus 3. Again, here the exponents are different. The first digit has an exponent of 10 raised to minus 2. The other one is having an exponent of 10 raised to minus 3. So will be, again I'm going to change the second number's decimal points. So 10 raised to minus 3. 10 raised to minus 3 can be changed into 10 raised to minus 2. Minus 3 should be changed to minus 2 by adding one digit. Plus 1. Again plus 1. It is a positive sign. So positive sign means it should be, decimal point should be shifted towards the left side. How many digits it should be shifted? 1 times. Minus 3 can be changed into minus 2 by adding 1 plus 1. So we need to shift the decimal point to 1 point left side. So we will get 0.48 into 10 raised to minus 2. Again what we have to do? We can subtract these two numbers. 2.5 minus 0.48 and we can take 10 raised to minus 2, that term outside. So we'll get 2.5 minus 0.48, put the bracket, and 10 to the power of minus 2 is the common term over here. So we'll get the answer as, what do we get? 2.5 minus 0.48. So it is 2.02 into 10 raised to minus 2. Okay. So this is how we are doing the addition, subtraction, multiplication and division using the scientific notation. Multiplication and division, no problem at all. You just need to multiply the digits, and if it is a multiplication you need to add the exponents, and if it is a division you need to subtract the exponents. But if you are doing addition and subtraction, we have to make the exponents same. We need to make the exponents same before doing the addition or subtraction. We can add or subtract the digits after making the exponents as the same. So you need to find out what is the change that should be done in order to make both exponents as the same. So if it is a plus 1 change or plus 2 change, if it is change is plus sign, then shift towards the left side, and if the change is a minus 1, then you have to shift it towards the right side. So this is how we are doing the addition and subtraction. I hope you have understood this. If you are having any doubts, you must contact me, clear it before doing the numerical problems. Thank you.